Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's episode, we're going to be talking about this idea of type punning. That is a way to get around the type system. Now, in our previous lessons, we've been talking about things like bit manipulation with ANDing, ORing, masking bits, or even using data structures like bit set. So make sure you check those out if you're not comfortable with bit manipulation or binary, because again, we're just going to be talking about, well, the same sort of idea, but a sort of unsafe way to do things here. And that's what this general technique known as type punning. So let's go ahead and dive to the Wikipedia page first today, and then we'll look at it on CPP reference here. But in computer science, type punning is basically a programming language technique that circumvents the type system. Now, C++ is a strongly typed and a statically typed system. That means when you declare something that's an int, for instance, on my architecture, that means it's going to be 4 bytes. We're always going to treat that data together as sort of 4 bytes. But sometimes it can be really convenient to just say, hey, I want to access each of the individual bytes. And the actual example that is given here is with sockets or network programming, right? When you connect to the internet, you're just getting a stream of bytes, and somehow you've got to interpret what those mean. Now, usually there's part of the code and the to give you some sort of key of what the actual bytes mean and the structure of the data. But again, if you're writing that network code, or maybe you need to serialize data or deserialize data, again, these are just some techniques that you'll need to work with. So we do have some tools like reinterpret cast, for instance, in C and C++ to mark when this is happening. But I'm going to go ahead and show you the sort of like old school way, and then we're going to talk about bitcast in another video just to give you another sort of casting tool that's a little bit more safer. So anyways, with that said here, I'm going to go to CPP reference here, and I'm just going to search for type punning here. And we'll see this term come up a few times in having to deal with unions. Now, if you haven't seen my video on unions, that's in this playlist as well, so you can get familiar with that. But let's just go ahead and see where it comes up here. I think if I search punning here, I was trying to find if this is like well-defined behavior. It certainly is in C, right? This is under the C language here. So, with a union, let me just go ahead and show the example here, right? I'm basically accessing this portion or this member here either with these members or either with these members here. Okay, that's the basic idea here. Now again, this could be kind of invalid here, I guess with the structure that they're giving, but that's the basic idea, right? The union chunk basically takes on one set of bytes, and then I can access it in 2 different ways. So same idea that we're going to do in C++. Let me go ahead and just illustrate that with a drawing, and then we'll get into some code to make this concrete. But let's just say I have a bunch of bytes here. 0, 1, 0, 1, 1, 0, whatever the pattern happens to be. And I'm going to chunk this up actually, just to be something a little bit more familiar. And let's say we have an int, or specifically I'm going to say int 32t, since we've talked about the fixed width types. So this will give us 4 bytes. Again, most systems, not all, I guess, are 8 bits per byte, so 32 bytes. Somebody could probably pick one system that has a different number of bits. But anyways, here is each of the individual bytes that we can access. Here we can draw some in, 8 bits per byte, whatever. But sometimes, again, as I've indicated here, I might want to take some, int 8t, or as we're going to learn here later, we have standard byte as well. In C++, and I might want to individually access these bytes here. Now, again, that could be because we have packed together a bunch of information into this one integer, like we have some structure, or like maybe this represents a pixel with red, green, blue, and alpha components, for instance, as we've taken a look at in previous videos. Or maybe this literally is a bit set where each bit means something, right? And we've looked at that data structure as well. So again, there's many reasons why we might want to do this. We just have to kind of do it carefully and responsibly, so to speak. So let's go ahead and see how to just do type punning, and then we'll introduce some more tools to do it safely here. So let me just give some example here. I'll start off with, and typically this is going to work a little bit easier if I'm just treating bytes with the unsigned type. That way I know the exact representation. It's just the bytes that I'm putting in. So that's one thing if you're streaming data in and out that you might want to consider. So anyways, especially if you're working like with text data, for instance. So let's just create some data. 255 is sort of a well-known number here. And let's just go ahead and write it out here. So I've included the format library here so that I can just write out those actual bits here. And let's just go ahead and start with that just to get us started here. And basically, if you haven't watched my format video, you can watch that as well. But this is basically going to pad 32 zeros, and then I want binary for the output here. So that's my format specifier for data here. Okay. So let's just go ahead and write out that 255 number here. I'll go ahead and compile this, and you can see, 255 is 8 ones here. And then I've got my next set of bytes, my next set of bytes, and then, my next set of bytes here. Okay. So that's basically what we can see here. So let's go ahead and do the type punning technique here, which again is allows us to access the data using a different type here. Okay, so something other than just saying, hey, this is an unsigned integer here. Okay, so let's go ahead and use a uint 8t. And for that, I'm going to need to include my fixed width types here. The standard int here for my fixed width types, which we covered in a recent video. And I'm just going to call this byte here. And basically what I want to do here is I want to, point this byte to this data here. Okay, now let's go ahead and try this. Let's see if this much compiles here. It's going to say, hey, cannot convert unsigned int to, uint 8t. These are different types here, right? And a u8 t here is effectively just an unsigned char. I guess that's what the type def is. So, how do we get around this? Well, this is where we can use a cast here, okay? So I could do a C-style cast here. Let's say uint 8t, and I want the actual pointer to that data here. So I put the star, dereference it, and voila, it still works here, okay? Now, what we've learned, though, in C++, in some of the casting videos, I can use reinterpret cast here. I've always got to spell that carefully. And this marks it just a little bit more safely. Let's go ahead and do that here. And, this still works here. So my recommendation, let me go ahead and put it here. Recommendation is to use a modern C++ style cast to do this style of type punning. Why? Because it sticks out a little bit more, and you could search for it, right? So you could see where you're actually handling this stuff here. Just it's kind of a syntactic thing here. Now, let's actually see what the advantage is. Now that I have this byte pointing to my data, right, I could basically use it like an iterator. So the goal is to use this as a per byte iterator. Okay. And that's basically the way that I'm thinking about that. That's again one of the points here. It's just data, and we're going to iterate through it. So I'm going to use the same sort of idea here, where I want to print out not my data this time, but my byte. And I've only got 8 of them, so we'll pad that as appropriate here. And my byte here, well, it's just a pointer, and I can offset it using our array syntax. And again, the brackets dereference and offset. So let's go ahead and do that here. And voila, the 0th byte matches here. Okay, all of my ones here. And just to make this a little bit more interesting and make sure it's working, let's go ahead and see byte, all the bytes here. Okay, so go ahead and run this, and you can see all the individual bytes here. And maybe we should just offset this, let's say 2 end lines on this guy here, just to give us a little bit of spacing there. There we go. So we can see each of the individual bytes there. Okay, so that's basically it. That can be the lesson here, but I want to show you a few more improvements that we could do here. One thing just to do, another example here. Let's do another example. I'll go ahead and comment out this one here. That more clearly shows the bytes. Sometimes I like to do these with like unsigned int data, but I'm going to set it to the hex values here, 00ff00, right? Just to give us a different number here. And as I've sort of encouraged here, putting the apostrophe to sort of break these up can also be nice here. So now you can see, this is the 3rd byte here. This would be the 2nd or first index here. So the 0th index matches here, and the 1st index matches there. the second index, and then of course the third index there. Okay, just so you can see some different values here. I don't know, let's put in a different value like EE there. There you go. So now you can see some slightly different patterns. Just make things a little bit more interesting. Okay, so, you know, again, the behavior here isn't really well defined, again, using this. That's why, again, I encourage the use of reinterpret cast. I think in C it is well defined. That's what I was reading ahead of preparing this video. Now, some improvements that we can make here that are sort of recommended here. This could be, like, if I access this as a int t here, let's see if this totally messes things up here. Like if I'm just like, hey, I'm pretty sure that's just an 8-bit data structure here. Let's run it here. Let's see if we get different values. I mean, yeah, we do. This does kind of mess things up here. So one thing that we can do to sort of improve this, you know, let's say one, you know, small improvement to show intention is to actually use standard byte. I don't have to go on CPP reference here. Let's go ahead and search for standard byte. And it is defined in these C standard definitions here. Okay, since C++17, and that defines it as an unsigned char. So it can be used to access, you know, raw memory, but it's not a character type and not an arithmetic type here. Okay, so it's kind of interesting here. And it also supports a lot of these bit shifting operations that we've previously been learning about. So if you're working with bits and bytes and need to like read in a stream, it's probably worth you know, using this type here, right? So let's get the benefit of a type system here. So let's go ahead and just copy this here. I'm going to use standard byte. I'll just call this byte 2 for now. Let's include C standard def is for the standard byte here. And let's make sure I update these guys here. So byte 2, byte 2, byte 2. And we'll cast to a standard byte here. Okay, let's see if that takes care of everything. Almost everything. I think we're going to get in trouble here with our format specifiers here. Oh, what else did I miss here? Did I miss anything else? I think I deleted a star here, which is the case here. And then, yeah, now it's my format specifiers here. So it doesn't like this. So ironically, let's see if I can just fix this by casting it to a int type. I could do that, or a short. Let's see if I did uint8t here and cast it. uint8t. Well, this one's always a tough one to spell on the keyboard. uint8t, and I think uint8t. Let's see if that gives me the right type here. Now that might give me a integral type here. That may, oh, I guess, okay, did work, which is good news. And we're getting the same results here, but we should probably just put an end line here, just so you can see if the results match. Okay, and then we got our byte type. Yeah, looks like that's working just fine. I didn't want to cast this in integer. You don't want to, you know, do too much work here. But again, now we're accessing as a byte. We can do the bitwise operations on it, no problem. And again, it's probably showing our intent to use standard byte for accessing things as a byte here, rather than, again, potentially making that mistake with an signed integer or whatever. So we know what the sort of representation is here. So with that said, I'll get ready to wrap us up. I did want to bring in one of the core guidelines here on type punning here. Let's see if I can search for it again. Type punning here. Let's see. It says don't use a union for type punning. Let's see, because it's, yeah, I mean, the core guidelines read that it's a undefined behavior to do this because it's sort of invisible. So again, I think it recommends a reinterpret cast, which is exactly what we did, which is good here. So something like this, exactly what we did, is the idea. And again, they're saying, you know, even this is sort of discouraged, but, you know, sometimes if you're doing systems level programming, you have to do this stuff and you want it to stick out. So that's sort of the best thing that you get here. I mean, because you could have your static analysis or literally just grep for the code to see where you're doing these things and see if there's anything tricky and know to jump into GDB and dump out the bytes and so on. If you see this, to make sure that things are working as they should. So it says if you must do this type of thing, probably because you're in a domain where you need to do it, all you're working with is a stream of untyped bytes, so you got to cast them to something and treat them as something. So you get this tool. And then we're going to talk about Bitcast in one of the next upcoming episodes. So stay subscribed and stay ready for that lesson. But with that said, I'll go ahead and end it here. And if you've been enjoying these lessons, as always, you can find on courses.mshut.io many C++ lessons, including the ones that you're following along with right here. You can track your progress if that's helpful to you. And otherwise, folks, thanks for your time and attention. Hopefully you've been enjoying these lessons. Hopefully this was something interesting for you, and hopefully you learned something new. So with that said, folks, I'll look forward to seeing you in the next lesson.